Okay, so for number 2, did you factor this function to 3x plus 2 and x minus 4? Okay, so if we're trying to find the zeros of this function, we want to know where the function equals 0. And so the x values where the function has a value of 0 are negative 2/3 and 4. Are we good? Okay, let's take a look at
that comes out as negative.
Oops, it is. Thank you. So that's going to change my signs here. Hold up, I guess. Okay, example 3. Now here we have a higher degree polynomial. This is a cubic. And so it's not a sum or difference of cubes, which we learned how to factor at the end of last semester. It's just a cubic. It's 4 terms. Who has an idea about how we could factor this one? Okay, what if we grouped? And we grouped the first 2 terms together and then grouped the second 2. Do you guys remember when we did some grouping? And say, so do the first 2 terms have any factors in common? An x squared. And so when we factor out the x squared, what are we left with? X plus 2. So do the second 2 terms have a factor in common such that when we factor it out, we're left with x plus 2? Yeah, a negative 5. So now when we look at this term versus this term, do you see that they have a common factor of x plus 2? So when we factor the x plus 2 out, what are we left with? X squared minus 5. Now, how do we use this to find the zeros? Well, when we look at the first factor here, it's pretty simple. We can just look at it and tell what would make this 0. Negative 2. But when we look at the second one, it's a little different. We know that we want this factor to equal 0. Is that hard to solve? No, you just move the 5 over. And so we get that x would be the positive or negative square root of 5. So this time I have real zeros. They're all real, but I have rational and irrational. So far we've done just ones that have real, and on this one we have real that were both rational and irrational. Okay, you try, whoops, let me put this f of x here so that we now have a function. You find where the zeros of this function are. Yes, sir?
Wait, wouldn't that mean you have 3 zeros?
We do. We have 1, 2, 3. Negative 2, positive root 5, and negative root 5.
Wait, how does that work?
Well, what this is it's a cubic.
Oh, okay.
And so, yes. And so we're going to start looking at these, and what does that mean? A cubic can have more bins in it. It can look like that.
Okay.
And this one does. All right, tomorrow you guys are welcome to sit anywhere you'd like. New semester, new seating arrangement. You pick. You can sit with whomever you want, wherever you want. If you get here first, you win.
You win.
You win whatever seat you want to sit in. It's a nice size phone.
Yeah, Garrett.
I'm just curious, how many of you got a cell phone before you were 12 years old? Raise your hand.
Wait, what grade did you go?
12, you turned 12 in 6th grade.
Okay, I got one in 6th grade.
You got one in 6th grade?
I got one a few days before I turned 12.
Merry Christmas. Victory.
I don't mind it. I don't mind it.
My daughter tells me that I'm making her awkward. Because all of her friends have a cell phone, and she doesn't. I think it is too.
I don't
Because
think it should be before, like, I think she should have one on the
sixth grade.
My sister she just got an iPhone for Christmas because she's been crying for a year that all her friends have an iPhone and she doesn't.
Okay. Yeah, we had that conversation, and she has an Instagram, so I looked at her Instagram to see what everybody got for Christmas, because when you're in sixth grade, you take a picture of it and post yourself. People in high school don't do that too? Okay. Yeah, they got a lot more stuff than she did. That's okay. She's not rude. You never asked?
I never asked for one and I got one.
I
was really happy.
Alright. Were you able to do this successfully? Okay. So you took out the x squared and you're left with x plus 3. So you took out a negative 2 and you're left with x plus 3. So if we want to know where this function equals 0, we get that x could be 3 or positive square root of 2 or negative square root of 2. Yes. The sad thing is all the correct answers are right here on this piece of paper. Alright. Now, some of you are going, wow, this is easy. And it is. Okay? So let's see what you can do with this one. Our fourth example, I guess it would be fifth if you called the try we did a few minutes ago problem. F of x equals x cubed minus x squared plus 16x minus 16. So this is 4 terms, so we're going to try that grouping thing again. It's going to sort of work. And let's see if you know what to do when you get stumped. Maybe you don't even get stumped. Carter, this year I'm going to try to only write in colors you can see easily.
So black. Okay.
Black and blue. Yep. Stars, no colors, yeah.
Getting beat in colors.
There are two kinds of people. Wait, in the second part, if you took out. No.
It's not gonna work out, okay?
Square that.
We take out a negative. We take a positive 16, and we're left with x minus 1. So that works out pretty well. So you got this x minus 1 and x squared plus 16. Did we get to this point? Alright, so this one's good. We get x equals 1. This one's not bad either, though, because you already know how to do this. If I took this factor and set it equal to 0, when I move the 16 over, it just becomes negative. But that's no big deal to you, because you know what to do when you're taking the square root of a negative. It's imaginary. So it's going to be positive or negative for I. So this function only has one real root. Only has one real 0. So this would cross the x-axis how many times? Once. This is my x-intercept. But it also has imaginary zeros. So if we were to sketch the graph of this one, we know it's going to cross right here at 1, and it's a cubic, and this cubic could do something like this up here. Okay? And later on, we'll learn how to do these graphs a little bit better, so we have a better understanding of what's going on. Alright, now, this is not a cubic. It's a quartic. It's a 4th degree. Who has an idea about how we can factor this polynomial 4th degree? You do. You treat it like it's what kind of function? A quadratic. We can factor this quartic like it's in quadratic form. And if we do, instead of x plus 6 and x minus 3, it's going to be x squared plus 6 and x squared minus 3. Okay, does that make sense to every single person in this room?
Yeah.
I need it to. Alright, so now if we want to know the zeros of this function, now that we have this function completely factored, we can take each factor and set it equal to 0 and solve. Now, some of you can do this in your head, and I'm all for that. So those of you that can do this in your head and don't need to write out this step, I'm good. This is going to give you x equals positive or negative I root 6. We can take the square root of negative 1. We can't take the square root of 6. And it doesn't simplify. So, and this would be x equals plus or minus root 3. So this one has 2 real zeros and 2 imaginary, or you could think of them as complex.
What do quartic functions look like?
What do quartic? They can look like a couple different things. When I think of a quartic, I think of it as looking like a W. But your W's can be very skewed. It could be like that. It could be upside down. It could actually, some of them don't even look like that at all. They look like a flattened out U. Like that. They can look very different. And when we start to graph them, we'll look at some of the different ways they can look.
Would that flatten out U turn into a W if you kept graphing it long enough?
The flattened out U would be one that looks more like, if we factored it, it would factor to something like that. And there won't be an extra dip in that one. Okay, now, this is a quartic that's not in quadratic form. So when we have a quartic that is in quadratic form, we should graph it, we should factor it that way. This one is not, so all we can do is our grouping and hope for the best. So, see if you can factor that. And then once you just get it factored, I want you to stop and wait for me. Okay, so did you get it to factor to x minus 2 times x cubed plus 8? Okay, well how many of you noticed that the second factor is a sum of cubes? Good! And a sum of cubes factors some more. It factors to cubed root plus cubed root, square it, product, square it. And this is where, once we have it completely factored, we would start looking for our zeros. So the first two are easy to see. What do you see? X equals 2 and x equals negative 2 and x equals, This doesn't factor anymore. How do I figure out what x equals? Okay, this is a perfect square and this is a perfect square, but this middle term doesn't work for us. So I can't make that one factor. What do you do to a quadratic when you can't make it factor? You use the quadratic formula. So we're going to go back to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're either going to get some irrational or we're going to get some imaginary answers here. So we do negative b plus or minus the square root of b squared minus 4 times A times C, all over 2 times A. And here I'm getting 4 minus 16 is negative 12. So these are imaginary. Negative 12 breaks down into negative 1 times 4 times 3. The square root of negative 1 is I. The square root of 4 is 2. I do not know the square root of 3. It must stay under. Divided by 2. And you see that everything divides by 2? So this simplifies to 1 plus or minus I root 3. So I have 1 plus I root 3 and 1 minus I root 3. And then I have my quadratic, and I have 1, 2, 3, 4 zeros. Woohoo! Thank you. I knew y'all would come in energized, enthusiastic. Last problem.
Yeah.
Okay, so we've done some quadratics, we've done some cubics, we've done some quartics, and now we have a 6-power polynomial, don't we? A 6-degree polynomial. What do we do? Treat it like a quadratic. That's exactly what we do. We treat it like it's a quadratic. So how does it factor?
Like a quadratic.
X1 and 6.
X cubed minus 6 and x cubed plus 1. So this is completely factored. Because 6 is not a perfect cube, I can't do anything else with this. I'm done. But this is a sum of cubes. This is, yeah. This is a cube. So it factors to cube root plus cube root, square it, product of the two, square it. I like the bigger screen, but I'm getting older, and my eyes could probably benefit from something larger.
You have a bigger one than mine. You have the 5, right?
I do.
So,
Alright, so this is the only easy looking one. So I know that X can be negative 1. That's one of my zeros. Alright, this one I know I can do quadratic formula for because I just did it and it worked. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is 1 plus or minus the square root of negative 3, which is I root 3, all over 2. Yeah, that works. So I get 1 plus I root 3 over 2. And if you just want to write it plus or minus, I'm fine with that, as long as you understand that it's actually 2 different things. So now we got this one right here. How do we deal with that one? Move the 6 over and take the cube root. Yep, that's all we do. So cube root of 6. Now remember, with your even roots you get plus or minus, but with your odd roots you do not. So my last 0 is the cube root of 6. Ta-da! And we're done. Okay, so you have a worksheet. We're just going to do the odds tonight. And it's factoring polynomials to find all zeros. So, real, imaginary. Some may be rational, some may be irrational. Some may be complex. And just doing the odds.
I mean, that's the 5. hold up.
So that's gonna be more.
Oh, yeah.